Learning AWS can be pretty intimidating. There's hundreds of services, and it can be difficult to understand which one is the right tool for what you're trying to accomplish. This video is going to help you navigate the complex world of AWS services. We're going to approach this by examining a standard 3-tier application architecture like you can see here. So let's take a look at this architecture now before peeling back the layers and revealing the AWS services behind the scenes. So what do we have here in this application architecture? We have a pretty standard 3-tier architecture here with a web backend layer. We have our application layer here, which is kind of, if you're in an organization with a service-oriented architecture, this will be pretty familiar. This is where all your backend services will be. And then you have your third tier here, which is your database layer. This includes, can be relational, could be a NoSQL database. You can also have some caching in there as well. And then we have a bunch of other components related to this. So we have deployment orchestration to hold on to our source code and then facilitate deploying it. We also have a monitoring component here for monitoring the state of the system. We have a load balancer here with a DNS pointing to that load balancer to distribute traffic. And then we have some other toolkits here on the right for event coordination. Say for instance, this application did some kind of something like Google where you have search query submission, and like every time that gets saved to a database, you want to trigger some kind of event in this layer over here. We have storage for that event. We have some analytical processing, a data warehouse, and finally some dashboarding for end users to examine that content. We also have some toolkits for rapid development to deploy a little bit faster as well. And over here, finally on the left-hand side, these two elements, so for user pools to define different users that are going to be interacting with your application, and then of course to serve cache content. So this is our pretty standard application here. Let's take a look now at some of the AWS services behind the scenes that replace each of these different elements. So the first one is for DNS. So what is the service that we want to use for DNS in AWS? So for AWS, that's going to be Amazon Route 53. And Route 53 is the service where you define all your DNS configuration, including where you're going to route traffic to from the internet. Also supports other things like health checks on your endpoints and any traffic shaping that you want to do. That's going to all be done in your Route 53 service. So it's great to be familiar with Route 53. You're probably going to be using it all the time if you were defining kind of externally facing APIs or endpoints. Now from there, your DNS will typically point to an endpoint for a load balancer. So for AWS, there's a couple options for load balancers, but the kind of top level category here is something called the Elastic Load Balancer service. And there's two variations for Elastic Load Balancer. There's what's called the Application Load Balancer, which operates at the L7 layer. And that's more applicable for those of you that want to use content from your HTTP headers to route your traffic. And for those of you that are looking for something a little bit more lower level, AWS also offers a network load balancer, which operates at the L4 level, which is a little bit more cost effective and supports higher throughput limits as well. So that's an Elastic Load Balancer and some of the different options that you may want to use. Now, in terms of your web backend layer over here, this is going to be the first kind of time that a request from the front end touches the back end. Now with compute, there's a couple different options that you can decide to leverage. And those compute options, it doesn't really matter if it's your web backend layer or your application layer. The compute options that you select for either of these two things will be the same. So what are the options that are available to us? So the first option is Amazon EC2. EC2 stands for Elastic Compute Cloud. Very, very old service. And the basic gist of this service is that you rent virtual machines that you pay for by the hour. And they're really convenient because with EC2 machines, you can set them up to do whatever you please. You can use them to host backend databases if you want. You can host a WordPress blog on it. You can create and deploy your application for a REST API. So it's a really flexible service that allows you to do whatever you want. But some of the drawbacks with EC2 can include just all the setup and configuration that you're going to have to go through to use it. So some folks shy away from EC2 in favor of something a little bit more hands-off. And for those of you that are interested in serverless, that's where our next point comes in, and that's AWS Lambda. So AWS Lambda is a serverless compute infrastructure option, and what that basically means is that you define what are called functions, and these functions are just snippets of code. They can be small or large pieces of code, and AWS does not require you to have to worry about any of the infrastructure as you had to do with EC2. You just basically write and deploy your functions, and AWS worries about deploying your application onto a container and then scaling that application whenever the number of requests to your Lambda function increase. So this is a really, really attractive model because Lambda is pay per invocation. So it's really cost effective for application workloads that have bursty traffic patterns, or for applications that have traffic during the day and then it kind of recedes down to nothing in the evening. So Lambda is a really, really popular service. It's getting more and more popular by the day, and it's definitely one to consider. If you want to learn more about AWS Lambda, you should check out my brand new Udemy course in the top right of this video. Now, if you're not into kind of deploying your infrastructure onto machines directly and you're not into using this serverless model, there is a third option for those of you that are more kind of Docker folks or Docker fans. And that third option is Amazon ECS. So ECS stands for Elastic Container Service. And there's also a variation of ECS called EKS, or Elastic Kubernetes Service. And essentially, ECS is just a service to help you manage your containers, helps you set up servers with integrated load balancing and auto scaling, helps you facilitate your deployments to those containers. So it's kind of like something in the middle between EC2 and Lambda. And if you're interested in learning more about like these three services and different compute options that are available to you, I have a video where I compare these three things. I'll put that in the comments or the description section below. So like I was kind of saying, the application layer doesn't really change in terms of the compute options. You have the same kind of fundamental building blocks that are available to you, regardless of if it's your web backend layer or your kind of business logic heavy application layer here. Now, another service that helps kind of facilitate the creation of your REST APIs and hosting those APIs is one that's called API Gateway over here. And API Gateway is a super, super powerful service because it offers additional functionality on top of just kind of using a load balancer to distribute your traffic to different nodes here. And the types of kind of features that API Gateway offers are things like API throttling or authorization on an API. Say, for example, you're building kind of a private API that you only want to be accessible from users in a user pool, which we're going to talk about next here. You can set up your API gateway to validate that a token is valid by integrating with the user pool service, or you can define your own. Also offers other features such as model validation, so you can define what types of models your API supports, and then have that validation performed before the request actually gets to your backend layer here. So you can do like a bunch of different combinations here. You can do your DNS pointing to your API gateway, which points to your load balancer, which points to your infrastructure layer. And that is if you want to take advantage of some of those features that I just described. So speaking of user pools, we just kind of touched on that. We might as well reveal the service here. And that's one called Amazon Cognito. So Amazon Cognito is kind of a very, very powerful but underrated service. And what it allows you to do is to create user pools. And these user pools, kind of similar to what you'd have on any kind of login and registration website. You create a user, they provide a login, a username, a phone number, a recovery option, all that kind of stuff. And so with Cognito, you can have users sign up for accounts directly within Cognito using the hosted UI. Or you can integrate with other third-party identity providers such as Google, Facebook, Amazon. So anytime you've seen like login with Amazon or login with Google or Facebook or any other identity provider, that could be integrated with Cognito as well. So very, very useful for applications that require user registration. And if you combine that with API Gateway, you can do things like ensuring that a user is part of a certain user group before the request can be validated, and that flows through to your backend layer here. So that's a little bit about Cognito. Let's kind of finish this three-tier architecture discussion and talk a little bit about the database layers now, or the storage / persistence layer. So a lot of applications have caching enabled on them just to increase performance on some lookups of items that are quite common, or maybe you just want to increase performance. So what's the AWS service that allows that to happen? So that service is called Elasticache. And Elasticache kind of comes in two different flavors. You can either go with the flavor that is Memcache based, or you can choose Redis. Now, Redis is probably the most popular one when people think about caches. I think Redis comes to mind almost immediately. But regardless of which you choose, when using Elasticache, it is a caching service, so it's going to be based on key value lookups, and you are going to have to worry about hosting that infrastructure. Essentially, you kind of own a cluster of nodes, and these are memory optimized nodes where they have plenty of memory to facilitate your application's needs, but you still have to worry about the maintenance of that cluster, and node replacement, hardware failures, things like that. It's a relatively hands-off service, but there are some nuances that you may need to know about in terms of maintenance and alarming and all that. Now, in terms of what should we store our database in? Should we store it in a relational database or a NoSQL database? So there's a bunch of different options here that you can choose from. So the one that AWS likes to push a lot is a relatively popular one called Amazon Aurora. Now, Amazon Aurora is an in-house built Amazon database that is compatible with both MySQL and Postgres. I believe Postgres is still in preview mode now. So it's a fully managed RDS database that kind of makes your life easier in terms of worrying about things like administration, monitoring, auto-scaling, storage auto-scaling, and compute auto-scaling. Also offers something called the Data API that you can use to call your RDS database using a REST API as opposed to a traditional kind of database connection. So there's a lot of features that are coming with Aurora, and you may really want to consider it if you're thinking about using a relational database. Now, a relatively similar service to that is Amazon RDS, or Relational Database Service. And where these two are different is that RDS is a database service that allows you to select which database configuration that you would like. So you get to pick from common database platforms such as MySQL, Postgres, Microsoft SQL Server, Oracle, Cassandra, and probably a couple other ones that I'm missing as well. So RDS is probably what I would think most people are familiar with, but a lot of customers are deciding to go with Aurora just because it's more of a hands-off option and just makes life easier. One other thing about Aurora is that it does offer a serverless compute model as well, where you don't need to worry about provisioning any type of hardware behind the scenes as you would with an RDS database. You can use the serverless model, and it's kind of like an auto-scaling type of database thing, similar to what Lambda did for EC2. Aurora serverless is doing for RDS. So it provisions your infrastructure whenever the request rate requires it. So if you have a bursty workload, it'll add more nodes and scale you up so that your database can handle more volume. So that's a little bit for RDS here. Let's talk about NoSQL database options now. Now, definitely the most popular NoSQL database that you're going to hear about a lot is DynamoDB. Now, DynamoDB is a NoSQL database that is optimized for key value lookups. It is a fully managed database service, so that means that you don't worry about anything with regards to infrastructure or hardware. All you really worry about is your scaling configuration, and DynamoDB handles the auto-scaling for you behind the scenes. And so it's a really, really powerful NoSQL database, and it's kind of used as the building block for much of the internet, really. If you take a look at one of the AWS white papers where DynamoDB unfortunately went down one day, it brought down with it a large part of the internet, including common services that we all love like Netflix and other websites as well. So DynamoDB is a super, super powerful and popular NoSQL database on AWS, and really this service is kind of at the heart of many other AWS services as well, like behind the scenes. So yeah, that's it for DynamoDB. Now, if you're a MongoDB type of person and you're coming to AWS, you don't want to learn DynamoDB, there is a service option for you. So AWS also offers what's called DocumentDB, like you see here. And DocumentDB, similar to Dynamo, is a fully managed service, but this time it is compatible with MongoDB so that you can use MongoDB as you normally would in a fully managed way. So that should satisfy any MongoDB lovers. And if you're looking for something that supports more flexible querying at scale, you may want to consider a service called OpenSearch. OpenSearch is the new name for the traditional Elasticsearch service. I believe AWS and Elasticsearch had a falling out, so AWS kind of came up with their own service here, but really this is Elasticsearch behind the scenes. Now, what OpenSearch allows you to do over some of these other NoSQL databases is perform queries that are more kind of fuzzy in nature. So give me all the records with value equals X, Y, and Z, and value 2 equaling something else and value 3 equaling something else. Also allows you to do some really powerful grouping features, dynamic grouping as well. Comes with Kibana as well, which is an open source dashboarding technology to take a look at your data inside your OpenSearch database. This has been used quite effectively as a replacement to RDS in some cases, but it's a really neat service that you should consider as well. Now, I wanted to pause here to talk about some other services that don't really fit the molds here, but kind of play a role in terms of packaged infrastructure. Because so far, what I've talked to you about here, these are all kind of lower level building block services. But AWS does offer these kind of packaged infrastructure services that make your life easier as a developer. You can tell that if you want to build this 3-tier application architecture here, there's a lot of moving pieces here. There's a different compute option, there's load balancing, there's API gateways, there's databases, there's a lot of stuff going on. So AWS does have some services that kind of offer a combination of these different elements as a single product. And so instead of having to worry about, each of the building blocks and deciding on your own which one you want to use, you can use these prepackaged infrastructure services that bundle this functionality together. And often they abstract some of the complexity away from you at the sacrifice of kind of configuration and control. So some of those different services are, the first one that I have for you here is Elastic Beanstalk. Now, Elastic Beanstalk is a pretty old service. It allows you to set up any kind of web application, could be a containerized web application as well. And it just makes it easier for you to set up your app with all these different components. So a backend layer, load balancing, also lets you set up auto scaling and monitoring. So it comes with a lot of the components here, but you manage it in one spot, which is the Elastic Beanstalk console. So you're still controlling the infrastructure with Elastic Beanstalk, but it's kind of like an orchestrator service. It'll go out to all these different services here and provision what it needs for the type of application that you're trying to deploy onto it. Now, another service that just came out pretty recently that does something similar is one that's called AppRunner. And AppRunner behind the scenes uses ECS and something called Fargate, which is a kind of a serverless mode for running containers where it uses provisioned containers that you can specify, but you don't need to worry about the infrastructure. So that's what AppRunner relies on. So with Elastic Beanstalk, it's orchestrating the deployment of your EC2 machines, your load balancers, and any other stuff that you may need. However, you still have visibility or insight into that infrastructure. You still need to worry about maintaining it. With AppRunner, it's a little bit different. All of the lower level components are abstracted away from you. You just kind of worry about your application configuration and deployment, and AppRunner will worry about deploying that onto your infrastructure and scaling it if it requires it. So that's another important service to know as well. And also there's another option here, which is Amazon Lightsail. And Lightsail is what I actually use for my personal AWS blog. You can check it out at beabetterdev.com. And it's another one of these prepackaged services that just makes your life easier. So it's similar to other kind of cloud vendors like I want to say GoDaddy or DigitalOcean, where you kind of select the type of stack that you want to set up for your application. And there's a bunch of different pricing models, kind of prepackaged pricing models where you don't have to worry about the details of kind of which node type is right for you, as you would have to do with your EC2 machines over here. You just pick different prepackaged options for compute, and the costs are reasonable as well. And in terms of what you can deploy on Lightsail, I use it to deploy my WordPress blog, but you can also use it to deploy a LAMP stack, a mean stack, a Ruby application. You can also use it to deploy your own containers. And you can also add other components as well, such as load balancing and auto scaling. So there's a lot of different features that are built into Lightsail, but it's a much more simplified and pared down version. So you can add all this extra stuff, but you're doing it within this kind of, I want to say, safe zone or safe version of the AWS console. So things are much more streamlined in Lightsail. You have very few options of types of things that you can do. And it's a very beginner friendly option for those of you that are just getting started. Not recommended for kind of production grade applications, but something great for smaller applications or even a WordPress blog, such as in my case. Now, another honorable mention that I did want to talk about briefly, for those of you that love GraphQL, maybe you're a front-end guy, you love GraphQL, AWS does offer a fully managed GraphQL as a service called Appsync. And Appsync just makes it easier for you to develop your GraphQL applications by providing you with that GraphQL functionality. So you can use it to integrate with other backend AWS services such as DynamoDB. You can use it to integrate with Lambda functions if you want to have some custom resolvers. And it can also scale really, really well too, completely transparently to you as an administrator, depending on the level of traffic that's hitting your application. So Appsync is another popular one that you can think about if you're a GraphQL user. Now, one other thing to mention as well is in terms of cached content. So for many of these web applications, you're going to be serving different types of cached content, whether that be image files, your JavaScript, your HTML, your CSS, anything that you may want to cache and basically put close to the end user so you can get better performance. And for that, you're going to be using a service called Amazon CloudFront. So CloudFront allows you to deploy a CloudFront distribution so you can have your application source deployed in, for example, North America. But what if you have customers that are located in Europe or Asia or Australia? If you don't use CloudFront, then any customer is going to have to hit that North America server, which does take some time. So there's going to be some performance degradation. With CloudFront, you can set up and deploy distributions that replicate some of your content from your general object storage, which we're going to talk about a little bit later, and then replicate that content to regional nodes that are located all across the world close to your end users. And what that allows you to do is get some better performance for much of this static content. So great for applications that want to optimize the experience for the user. Okay, so far we talked about quite a few concepts. We talked about like routing, APIs, user pools, load balancing, compute, databases, packaged infrastructure, caching. Now I want to talk about some other components in terms of like how do we actually deploy and monitor these applications. So in terms of deployment, there's actually 4 different smaller services, I want to say, that AWS provides. And these kind of work hand in hand for a deployment pipeline. So let's peel these back one by one. So the first service at hand is code commit. Now what code commit is basically is for storing your source code. So you can either store your source code directly inside code commit as a service, or you can integrate code commit with third-party providers such as GitHub if you have a private GitHub repository. Really the option is up to you. Now, code commit on its own isn't too impressive or too powerful, but it's the integration with some of these other services that do make it powerful. And the next one is code build. Now, code build allows you to take your source that's located in code commit or any other kind of third-party connected repository and then build that up into artifacts. It also allows you to create and run tests in a test environment for your source code. And when you combine that with some other components that we're going to get to in a second, you can build some pretty sophisticated CI/CD pipelines that have multiple different steps here in terms of running your unit tests and your integration tests and all that. But we'll get to that in a second here. So yeah, code build is for building and testing your source code. Now, how do we actually deploy that source code out to our compute infrastructure here? Well, that's the job for code deploy. And like the name kind of implies, it's all about taking these artifacts that are built in the build step and then knowing how to integrate with these other compute layers to actually deploy your artifacts onto these different types of services. So that's what code deploy is all about. So far, these are kind of individual building blocks that are chained together, but don't really give you a way to kind of orchestrate a sophisticated deployment pipeline. And that's what this last service is for. And that's called, as you may imagine, Code Pipeline. Now, Code Pipeline is kind of like a deployment orchestration service. So Code Pipeline allows you to define a kind of a workflow of the different stages that your application will run through. So for instance, you have your your source code, then you have a build step, then you have a test step, and then maybe you deploy that source code to a test environment. And then after the test, you run another set of tests. And then after that, maybe you deploy to your production environment. So code pipeline allows you to take these smaller building blocks here and weave them together to build a pretty sophisticated CI/CD pipeline. And if you're interested, I do have a video on this where I kind of walk you through how to set up a pipeline with all these different components here as well. I'll put a link to that in the description so you can check that out later. So that's it for deployments. Now, what about monitoring? And I should say that I have monitoring here kind of barred over kind of this section of the diagram, but monitoring really applies to this entire diagram. For everything that we've discussed so far and everything that we will discuss, monitoring is a very important concept. And if you're running any kind of production workload, you need to have monitoring configured and know where to look to determine when things are going wrong and you need to step in, or when things are fine and you can go home and sleep nicely on your bed. So there's two key services that are involved in monitoring. And the first one, let's start on the right here, and that's Amazon CloudWatch. So CloudWatch, I want to call it kind of like an umbrella service because there's a lot of different features that are inside CloudWatch. But by far the most important feature, in my opinion, is the ability to evaluate your metrics on many of these other AWS services. So you can go into CloudWatch and view different metrics on your EC2 machines to see over time in chart format, what is its CPU utilization? What is its memory utilization? For your Lambda, maybe you want to know what are the concurrent number of invocations or all the invocations in one day, the count that is. So you would use CloudWatch to derive that kind of information. Another useful feature is logging. So for many of these applications, you're going to be emitting application logs in terms of what your application is doing. For other services that are just kind of managed services that sit on their own, often these services will integrate with CloudWatch to give you kind of administration level events whenever things are happening on the services if you're using that piece of infrastructure. So you're going to be using CloudWatch quite a bit. And in fact, they just released a new feature recently called CloudWatch Insights that lets you search over very, very large volumes of CloudWatch data using kind of like a SQL style language. So it makes it very, very convenient to find certain log lines if you're looking for them in just kind of a giant mess of log files. Now, the other service that's important in terms of monitoring is one that's called CloudTrail. And CloudTrail is a little bit different than CloudWatch. CloudWatch helps you monitor the state of your applications in your AWS account. CloudTrail is more in terms of kind of an audit trail of the operations that are being performed on your infrastructure here. Not only the operations that are being performed, but who is performing those operations. Whether or not that's an application, so like a Lambda function calling a database, or maybe it's a user that kind of went rogue and maybe they're deleting all your infrastructure. CloudTrail is going to offer you different types of events that allow you to gain insight into who is accessing different services and what they are doing on those services. So the types of events can either be at the kind of control or administration level. Those are just kind of when your infrastructure gets provisioned or deleted or modified in any way. There's also data level events, and the kind of collection of events is called trails. So the data level events give you a little bit more granular data. So for something, if you configured it on a DynamoDB table, it'll give you log information on every single request that comes to your table. I don't advise it. You're going to be chewing through a lot of bandwidth for basically log storage, but you can enable that if there's a situation where you kind of need to know who is hitting this database. And then the third one is kind of a proactive one. It's called Insights. And Insights, you can configure it to automatically monitor your account. And AWS uses machine learning to monitor the CloudTrail events for any anomalies. So very useful for kind of being proactive about security threats. Now, one other service that I think we should mention at this point that is kind of similar to monitoring in that it applies to any of these different infrastructure components is a service called Identity and Access Management, which is often referred to as IAM for short. So IAM is kind of a security management service for AWS. You can you create high-level entities such as users or roles, and associated with these users are policies. Now, these policies are important because by default, a user will not have any kind of permissions to do anything on AWS unless you define a IAM policy that gives that user to perform that action. In other words, AWS Security Management uses an implicit deny operation in that you're denied access to everything unless someone says otherwise. So that's what you do in IAM. You create these IAM policies, you attach these policies to users, you can assign users to different groups that have a kind of a policy permission set predefined and applied to anyone in the group. And you can also use it to create accounts that users can log in directly. So a developer A can have their own account, developer B can have their own, so on and so forth. So again, identity management is definitely something to be very familiar with. You're going to be using it pretty much, I want to say, every day if you're working with AWS, because you're always, trying to get access to something. If you're experimenting with a new service or feature, you're going to need to give yourself access. So get familiar with it. You're going to want to know about it. And if you haven't spent the time to learn it, you're going to kind of stumble over a lot of ambiguous permission-related errors. And I do have a video on IAM that you should definitely check out to learn about these concepts more in detail. And so now I want to talk about two components here. I want to talk about rapid development and then some infrastructure as code components as well. So let me just erase some of this. And I realize I just made a mistake as I'm erasing it now. This stuff was kind of positioned in the wrong way in the layer beneath it, but I hope you forgive me. So this first section here is for infrastructure as code. Now, for those of you that are living under a rock for the past 10 years, infrastructure as code is the preferred way to create and manage your infrastructure. No one really goes into the console anymore to create things and manage your infrastructure unless it's kind of your first time doing it and you're just experimenting. It's much more preferred to write your infrastructure in a code format or a configuration format so that it can be easily picked up and deployed to a new environment. And CloudFormation is one of the options that allows you to do that. Now, CloudFormation is a service that allows you to write JSON or YAML-based kind of configuration files. And so you upload these files to CloudFormation, and CloudFormation will be responsible for calling these other AWS services to provision your infrastructure. So for example, you can write a template file here that has a DynamoDB table in it and maybe a Lambda function in it. And when you upload your change set here into CloudFormation, CloudFormation will go and create your Lambda function. It'll go and create your DynamoDB table. It's very, very convenient. It's pretty quick. However, it does have some downfalls. And the specific one is that writing your infrastructure as YAML or JSON kind of sucks. And that's where CDK comes in. It kind of fixes this problem. CDK stands for Cloud Development Kit, and it is a method of writing your infrastructure as code that is a little bit more fluent for us developers. It involves you writing actual code. So, you have access to loops, primitive functions, and what this allows you to do is be a little bit more expressive with your infrastructure definition files so that you can be a little bit more dynamic and structure your code in a much simpler way using functions. Using just general CloudFormation YAML files, it gets annoying quick. You don't have access to things like autocomplete, whereas with CDK you do. And the cool thing about CDK especially is that it's very easy to use what are called higher level constructs. And these constructs can contain an entire application specification. So you can have a construct that's an entire serverless architecture that contains a Lambda function, contains a DynamoDB table, contains, a load balancer with API gateway and a Cognito user pool. All you have to do is use that construct, and it's just one line that you write in your CDK code. Now, behind the scenes, CDK does generate the code that you write into CloudFormation, and then CloudFormation is the one that deploys that out into AWS, but it's just a much more preferred way, and in my opinion, easier way to deploy your infrastructure out to the cloud. Now, there are some other options that you can use for infrastructure as code, such as, I believe, Terraform, and I think the other one is called Pulumi or something like that. You can also use those that integrate with AWS as well, but if you're looking to do everything native in AWS, you probably want to use CDK. Also learn CloudFormation while you're at it as well. Now, two services in the rapid development category that are of note are firstly AWS Amplify. So AWS Amplify is kind of a toolkit style service that allows you to rapidly build and deploy entire applications here. So where Amplify is different is that for it's primarily a CLI tool, so you're going to be using the CLI a lot. And secondly, it focuses more on the functionality and not necessarily on the infrastructure of what you're trying to provision. So for example, with Amplify, you can run a very simple command to add an API. It's literally add API. And behind the scenes, Amplify, it'll deploy maybe a Lambda function with an API gateway. Allows you to add things such as user authentication and authorization. Behind the scenes, it'll give you a Cognito user pool. You can add things such as a relational database. It'll give you an Aurora, probably serverless database that you can use. So it's much more focused on the functionality. And for a lot of people, that's great. Amplify is a great choice because, maybe they're coming from a different cloud provider. You don't want to learn about all this different stuff. Maybe they're more overwhelmed than you and they haven't watched this video yet and they don't know about all these different AWS services. But Amplify is a great abstraction for you. But the one problem with it is that it's the abstraction. So it's great when everything is working correctly, but anytime something breaks or something isn't quite working as it should, you're going to need to dive into these independent services. And if you're using Amplify, you probably don't know anything about these other AWS services. So that's going to be a pretty big challenge. So if you want to stay within a well-defined box, then Amplify is great. And if you want to venture out of that box, you probably shouldn't use Amplify and should just write your own CDK code and understand these other AWS services before you get into them. But Amplify is great for some of you that maybe you don't care about AWS services and you just want to focus on the functionality. So that's where Amplify is great. Now we have SAM. So SAM stands for Serverless Application Model, and SAM is great in terms of providing shorthands of common infrastructure setups that would typically be written in CloudFormation. There's SAM templates that you can use that kind of similar to what those higher order constructs do in CDK, similar idea with SAM. So it can kind of handle much of the complexity of the setup for you. You'll need to find a couple specifications or a couple fields, and the other stuff, it gives intelligent kind of default. So SAM is also great for local testing of your Lambda functions. So you can use SAM to build and run your Lambda functions locally before you deploy them into AWS. So that's another great reason to use it as well. All right, so let's talk about this kind of half of this diagram over here. And so I put this hypothetical use case here. So search query submission. I was thinking maybe we're building an application here that's similar to Google. So you have someone that's submitting a request to our application layer here through our backend. Maybe someone is searching for, I don't know, AWS on Google. Someone's going to store that in a database somewhere, right? And then, as a typical service-oriented architecture, you probably want to send a notification out to other microservices that, hey, someone searched for this thing. Maybe someone else or some other microservice cares about it. Maybe an analytics service or some other type of service. So what do we use for event coordination or pub sub or notifications of other services that something has changed in our application? So there's a couple different services at play here. So there's a little bit of a misalignment here, but that's okay. So the first one is what is called SNS, so Simple Notification Service. And SNS is basically a pub sub service, and it is the pub in the sub. So it is responsible for publishing notifications to a topic, and a topic can have many different subscribers. So the idea is that kind of a domain model owner, such as, search query service or whatever, whenever it kind of puts an entry into its database, it wants to notify other services that, hey, someone put something into my system, you guys should check this out. That system will use an SNS topic that they publish to notify these other microservices that something changed. So it is the publisher, and the subscribers can be many different types of infrastructure. You can have other AWS services that are your subscribers, such as a Lambda function. You can have a HTTP endpoint that exists on maybe an EC2 instance or something like that. You can also have a very common one, which is an SQS queue or a simple queue service queue. And so SQS is simple queue service, and this service is effectively responsible for holding messages so that you can process them at a later time. And so you define queues, and queues can be connected to from many different types of compute infrastructure. So you can connect your queue to a Lambda function or an EC2 machine or an ECS task. And those pieces of infrastructure will pull your queue for new messages and then perform some type of action when it finds new messages in the queue. So typically people set up an SNS to an SQS. So the SNS topic being the publisher and the SQS queue being the subscriber. And if you're confused at all between the difference of these two services, I do have a video on this that I discuss this ad nauseum, and I'll put that in the description so that you can check that out as well. But basically, if you want to tell other people about data or data changes, use SNS. If you want to be notified of when something changes in someone else's data, use SQS. That's the basic gist of it. Now, there is another service that's pretty similar to SNS, and it's one that's called Eventbridge. And Eventbridge is very, very similar in terms of what SNS offers, although it does offer some distinct benefits. So first of all, instead of SNS topics, Eventbridge uses this concept of event buses. And you can integrate your Eventbridge event bus with many different kind of application actions all across AWS. So for instance, maybe you want to integrate your Eventbridge with whenever an EC2 machine gets terminated. Maybe that's some kind of operation that you're interested in, or whenever a Lambda function gets updated, or whenever the configuration on your Dynamo table gets changed. You can integrate those events into Eventbridge, and then you can define rules that specify who to deliver these events to. So similar to how SNS has subscribers, Eventbridge also has subscribers, and you define these rules and target groups of who to deliver these messages to depending on the type of event. Now, where Eventbridge really shines over something like SNS is that it has two important features. The first one is something that's called schema discovery. So if you are using SNS and you're publishing to your topic and someone is getting a message in your SQS queue, what does the schema of that message look like? What does the format of the message look like? Does it have, is it a JSON? Is it an XML file? Does it have, foo as a key and bar as a value? Like, is it an array? Like, what's in there? So Eventbridge allows you to define these schema definitions to help subscribers get access to the models that are going to be delivered from the Eventbridge event bus, which is a very, very nifty feature. And it also allows you to search through different schemas to maybe find the one that's necessary for your application. Another important feature is third-party integrations, and this is something that's really cool with Eventbridge. So an example third-party integration that you can work with is something like Shopify. So Shopify has native integration with Eventbridge. So what that means is that anytime someone places an order on your Shopify e-commerce website, that can be directly integrated into Eventbridge. And then you can have specific rules set up to deliver that notification to maybe a microservice over here or a backend service that cares about those updates. Or maybe you just want to deliver that to general object storage, which can happen as well. But Eventbridge is great because it allows for these third-party integrations such as Shopify, PagerDuty, and many, many others. And that's not really natively offered in SNS. So that's where it kind of shines. Now, another service that's in this kind of event and coordination department, let me just erase this here so it looks pretty smooth, is step functions. And honestly, out of all of these, step functions are one of my favorite services offered in all of AWS. And what step functions allow you to do is to define kind of workflows. So it's more like, I want to draw it out, but maybe I won't, but you define like workflows and different steps that you have. So you have a starting step, and then next you want to do like X step and then Y step. You can have conditional logic in your step function workflows. And so what this allows you to do is build things like, a customer ordering workflow, where the first step is to validate the details of the order. The next step is to package that order in the warehouse. The next step is to, send out delivery notifications and send out a notification to the customer. All of that can be modeled in a step function workflow, and you can have kind of fail-safe and conditional logic in that workflow. So if anything fails, then a different path or a different choice is taken, and it offers direct integration with many other AWS services. So you can use a service like AWS Lambda to kind of glue different parts of the workflow together, and this is going to be completely serverless. So in summary, step functions are kind of this orchestration service that allows you to define these very sophisticated and large workflows that may run through many, many steps. So after you've kind of done your event delegation here, maybe you want to store copies of those events in object storage, or maybe you want to kind of replicate whatever's in your Dynamo or Aurora table or RDS table into just some cheap, cost-effective general object storage. So what service would you use for that? Well, the service you're going to be using is one that is one of the oldest in AWS, and that's called Amazon S3. It stands for Simple Storage Service, and it is just your kitchen sink of data storage. Very cheap, very scalable. You can store like basically exabytes or petabytes of data in here, just massive, massive amounts at very, very affordable rates. And you can also move your data over time into cold storage to get even better price points. However, it can scale really well. So when we were talking about like caching earlier, when we were talking about CloudFront, you would typically store your asset files in your S3 buckets and then connect that to your CloudFront distribution so that it can be replicated to CloudFront and served to all your customers around the world. So S3 can be used to store basically any type of file, images, CSS, video, any type of media that you can think of, you can store in S3. There are some pretty reasonable limits on file sizes, so you're gonna have to check that out if you wanna upload some massive files, but S3 is a super, super important service. You should definitely know about it if you're learning AWS. Okay, so now for analytical processing. Say we got our data into S3 now, someone saved it into their database over here, we dispatched an event, then we stored it in S3. Now we want to run some analytics on it. So what infrastructure option should we use for that? So I want to start with the bottom one here, EMR. And EMR is a large-scale distributed data processing system. So it allows you to run many different frameworks, including the most common ones. So Spark clusters, Hive, Presto. You can even run it in a serverless mode now. But EMR is going to be the service where you're going to do just massive number crunching to perform some kind of analytics. So the other option to use instead of EMR is one that I'm a really big fan of, which is Amazon Athena. And Athena is a completely serverless big data processing or analytics service. So how it works is that you can keep your data stored in S3. You don't need to load it into anywhere as you may with EMR, but you keep your data stored in S3. Athena will directly connect to your S3 data, crawl your data, automatically detect the schema of the data of whatever you have in your buckets, and then create these kind of tables that you can query using SQL. And so whenever you dispatch a job to Athena, it uses AWS's infrastructure behind the scenes to prioritize the request. So you can run massive, massive queries on data that is already stored in S3 using Amazon Athena, a really, really powerful analytics service and just number crunching service that's a very viable option when compared to EMR. Now, our next step is the data warehouse. So where do we actually want to store this data for things like, business intelligence or any types of analytics that we may want to perform on it? We don't want to store that in something like DocumentDB, Dynamo, or any of these RDS options over here because they're not really meant for that. So the service that you'd want to use for that type of operation is Amazon Redshift. And Amazon Redshift is a columnar style database that allows you to perform some very, very large queries concurrently, so it can support many, many users at the same time. It is a little bit expensive, but they do offer a serverless mode. I swear, everything is going serverless these days. Like all of these services now have some kind of serverless variation. But anyways, they offer a kind of a provision mode where you can provision the nodes in a distributed way, or there's a serverless mode where it's kind of a pay-per-use type model. However, that's where you're going to be running your workloads for your kind of OLAP style queries. That's going to happen in Redshift. And in fact, there is kind of a connection you can do with Redshift and S3. So say there's like no analytics that you want to do, you can just deliver data to S3 and then set up an automatic load job to load that into Redshift so that it can be available for this OLAP style querying. So Redshift is another great one for data engineers, business intelligence users, anyone that wants to interact with data at scale using SQL. And the next one here is dashboarding. So dashboarding, for that, I would use QuickSight. So QuickSight is a tool that is great for end users. So you give users their independent logins. They can access data, whether it be in Redshift or S3 or anything else. They can create these kind of business-facing dashboards. So similar to what I think it's called Microsoft BI or Power BI did for Microsoft. Redshift kind of does for AWS. So that's what your end users can use to explore your data that's located in many of these different AWS services. And one final thing before I let you go is this network boundary here. So AWS is pretty big on security, so it does offer a service that allows you to isolate all of your resources into a specific isolated network. And the service that allows you to do that is Amazon VPC or Virtual Private Cloud. And this service allows you to create your own VPCs that are basically private networking spaces for your infrastructure to exist in. So it's completely separate from all other AWS users. It's just your networking space, and you can connect your VPCs to other VPCs so that if you want to talk to other services and maybe a different account, you can open up your VPC so that your infrastructure is callable from the public internet. You can have very, very large VPCs that host many different microservices here or service-oriented architectures. So there's a lot you can do with VPCs in terms of defining the setup and configuration, in terms of the security. So there's a lot you can do with VPCs in terms of setup to isolate your resources from any other system, and also allows you to define some security rules to make sure that your infrastructure is protected from any outside actor. So if you enjoyed this video, I'm going to put links in the description section to what I think are pertinent videos on all of these different AWS services. And if you want to learn more, check out other ones here on the right. And thanks so much for watching. I hope you learned a lot about AWS services. Thanks so much, and I'll see you next time.